Hello, this short video will show you some of the new exciting news of IBM Runbook Automation as it has been released in the second quarter 2018. The addition of this release is a conditional automation, multi-target automation on conditional gateway concepts, which will be shown in this video. This shows a sample workflow to react on an incident where you see different boxes here representing automations to be taken out to find, in this example, systems affected by any kind of incident. Other automations in this workflow are being used to prepare the output of the first automation, which does the actual finding of affected systems. Other automations, like you see here, the systems need and change automation, are being used as automation to do the decision where to run. And finally, you have at the end a check install package automation, where you do some workload automation in order to react on the incident on those targets where it's needed. The automation who does the decision where to another automation needs to run, we call condition gateway. Since a condition gateway returns very often a list of systems where something has to be taken out, where an automation has to run, we call the automation running the same script on multiple endpoints a multi-target automation. This slide shows you how the workflow, as expressed as a diagram in the slide before, is being expressed in multiple steps, in 6 steps of the automation in Runbook Automation. What has been explained as concept in the slides before looks like this in our normal Runbook Automation execution flow. So here you see that as only parameter of that runbook, you are specifying a package name, and which is the name of a package to be checked on our artificial example here. And in the first step here, we have a description of what we are doing in the runbook. The package name is to be checked in this runbook at the final step. Now it's me to explain you in this runbook how the runbook finds out on which systems this package has to be checked. In this step of the runbook, we will have an automation, and this automation provides the information about all systems of your data centers which are running a specific operating system and on which a package has to be checked. The automation in this step is simple an example. The example returns a list of systems which are only working in our lab environment here. So if you ever try this runbook in your environment, you need to edit the automation and put real system names in there to be returned instead. The next step automation will simply use the returned values, the returned output of the automation before, to calculate the number of systems per operating systems which needs to be checked in this incident. A following automation is using the output of the first automation and now calculates a target list of endpoints which needs to be checked. So this will only shows you as a sample that an output of one automation can be used by multiple following automations in different ways to create different outputs. But it is more or less also possible to combine the two last automations to one. Now we are coming to a step where the gateway automation plays an important role. This gateway automation now takes all the pre-formatted outputs from the automations before and makes a decision on which systems now the following automation has to run. Before we run that gateway automation, let's have a closer look on the parameters of that gateway automation. And let me explain a bit that you are able to use this gateway automation for your needs. First of all, a gateway automation runs as a local script automation. Therefore, you should specify it as target and as its user fixed values. I would always recommend to use localhost as a value for the target. And yeah, if it's okay in your environment, also use root or another functional runbook automation user ID to run that local script automation. The really important parameters which are being used by the logic of the gateway automations are input, key, operator, value, and EPS, which stands for endpoints. Let me start to explain. Input is whatever has been created as output from an automation running before. The input has to follow some certain rules. For this gateway automation, the rule is that you always have key value pairs separated by colons. And later you can check now for keys equals or greater than or less than a specific value to make this gateway automations to evaluate to true. The next is key opper value. Those are three parameters are specifying which key of the input is to be checked. So for example, here in this case, we want to check the key named Linux. For the operator, we can specify less than, greater than, equals to, less than, equal, and so on. And a value is a numeric value to be checked here. So the concept of this gateway automation is to check key value pairs where the value is always a numeric value. It is an example, so you could create other gateway automations doing other checks. However, this gateway automation is doing this kind of checks of checking key with values, with numeric values, as example. As last parameter, which is very important to understand, is the parameter EPS, which stands for endpoints. Here you need to specify a comma-separated list of endpoint system names on which a following automation has to run. The logic is whenever the input of this gateway automation is being evaluated to true, depending on what you specified for key operand value, then EPS value is being returned. If the input does not match to key opper value, then the gateway automation will return an empty target list instead. So in this way, you can specify a condition when the key opper value is not evaluated to true compared to the input, then nothing has been done by the following automation. In this example, we created a gateway automation before with values where the evaluation was becoming true. So there has been more than 0 Linux systems which needs to be checked. Therefore, the gateway automation now returns an multi-target suitable target specification. It is a list of host names, a comma-separated list of host names in square brackets, and this is the format suitable for a multi-target automation to be followed next step. as you see, the multi-target automation is now running on all of those systems which have been specified as input to its target parameter and calculated by the gateway automation step before. The scripts will, in this case here, now check for the package to be installed and also give some information about which version is installed and so on. Very important to know is that the script is being executed on all specified targets in parallel. A multi-target automation always ends with the status successful. So even if the multi-target list specified as input is empty, the automation will end with status successful. However, what you see here at the end of any multi-target automation, there's a summary on which systems the multi-target automation failed. This can be, for example, the system name is not reachable. On which systems the script was unsuccessful, so the system was reachable, but the script was having some trouble on the system. And finally, where the script was being executed successfully, so the target system was reachable and the script did what it needed to do. The output of those kind of failed, unsuccessful, and successful statements of a multi-target automation is suitable to be used as input for any other automation following. So therefore, if you have a multi-target automation being executed on 100 systems, but it fails on 10 systems, then you can use the output specified here, where it says unsuccessful on the following 10 systems, in a following automation to run a cleanup script on those 10 systems. Gateway automations, as shown in this video here, and output post-processing script automations, also shown in this video before, need to run on some targets as well as real script automations do. Very convenient is to run those kind of automations on a local server where RBA itself is being installed. So if you chose to install RBA server on with a private deployment, then you specify as target for those local script execution local host, and then the gateway automations and post-processing scripts will run on that local server. Remember, you still have to prepare that local server the same way as you prepare endpoint systems. That means you have to copy the SSH key to the local host system where RBA is being installed in order to be able to run gateway automations or post-processing scripts. You might choose to specify a jump server for script execution. You can use jump servers for private deployed installations of Runbook automations as well as for the public cloud of Ring. In this case, local script executions will most likely be executed on those jump server, because when you specify localhost as target while you have specified a jump server for script execution, then localhost is being evaluated as the localhost of the jump server and not the localhost of the RBA server. That's important to know. So this setup is also the only setup what you can use as jump server for local script executions when you run the RBA as public cloud of Ring, because there you do not have a local server, no local RBA server to run local automations. Thanks for listening to me and watching a short introduction video to the new features being added to the recent release of IBM Runbook Automation. This video is being placed on the Center of Excellence for Runbook Automation as always. For more information about the features, look at the Knowledge Center of Runbook Automation. The runbook which has been shown in this video is being made publicly available on our public GitHub repository. There you can download and play around with it. Always remember, it is a conceptual runbook. It is just there for you to understand gateway automations and multi-target automations. We expect that this automation, this runbook by itself has no value in your environment. However, you can make use of the automations inside and can learn from its concepts. Thanks a lot and have a nice day.